Okay, in activity 3.3 we are given various things to do, and the first of them, sorry, let me just get rid of that. We are asked in part A to work out the circumference C of a circle when we are given the formula C equals 2 pi r. C can vary because you can have a circle of different circumferences, and radius also varies. So as the radius gets bigger, the circumference gets bigger. As the radius gets smaller, the circumference gets smaller. But 2 doesn't change, and pi is also another constant that does not change. So the only two variables in this formula are C and r. Now we are told that in the first instance r equals 2. So if r equals 2, then we can say C equals 2 times pi times 2. Now I could write it like that, but it's a bit unconventional. We tend, if we're multiplying things together and they're numbers, then we put them either in brackets or with a multiplication sign. If it's a letter, we just write it as we've written it here, with just the letter r. But once you replace that r by a value, I prefer to put it inside a bracket. So now all we need to do with our calculator is work out 2 times pi times 2. 2 times pi times 2, which according to my calculator equals 12.56637 ... I'll say, because it does go on. And we are asked to give the answer to 3 significant figures. So, as we did in the previous exercise, the first significant figure is 1, the second significant figure is 2, the third significant figure is 5. We need to look at the fourth one, which is 6 in this case. 6 is bigger than 5, therefore it rounds the 5 up to become 6. So we have 12.6 as our value to 3 significant figures. Do the next part in the same way, but now r, we are told, is equal to 5. So when r equals 5, the same formula applies. C equals 2 pi r, 2 pi times r, which is 5 in this case. And if we work that out, then we can get the answer of 31.4159. I needn't put all of them in because I bear in mind that I only want 3 significant figures, so as long as I've got 4 I can work it out. First significant figure, the second, the third, and then the fourth is 1. 1 is less than 5, so it does not change the 4. So we're left with 31.4 to 3 significant figures. Now part B, similar idea, but they've given us another formula now. The area of a circle is given by the formula A equals pi r squared, where r is the radius of the circle. So in this particular case, A is a variable, the area, and r is another variable representing the radius of the circle. So now if r equals 1.5, then A, the area of that circle, is given by pi times, I'll put it in brackets, 1.5 squared. And I can use my calculator in different ways to get this. I think I'll just do it as pi times 1.5 times 1.5 equals 7.06858, and so on. And we count 3 significant figures. 1 is 7, 2, 3. We look at the fourth one, which is 8. 8 is more than 5, so the 6 is rounded up to 7, and we get 7.07 to 3 significant figures. And when R in the second part of part B is 3.7, then the area is calculated by the same formula, pi times R squared. R is 3.7 in this case, so pi times 3.7 squared, you use your calculator now, pi times 3.7 times 3.7 equals 43.008 ... 3 significant figures, so 1, 2, 3. The fourth significant digit is 0, so 0 is less than 5, so it does not change the third position. So that third 0, the 0 in that position stays unchanged, so we've got as our answer 43.0 to 3 significant figures. Notice that 43.0 is actually the same size. It's equal in value to 43. So you may well ask, why do we bother to put the 0.0 in this particular case? And the reason for that is a bit subtle. If a reader sees 43 without knowing the details of how it was obtained, they could well assume that you are giving your answer correct to 2 significant figures, whereas in fact you know that you've done it to 3 significant figures. By putting the 0.0 in, you are emphasizing the fact that I've worked out this value and I know that it is not 43.1, it is not 42.9. To 3 significant figures, it is 43.0. So you're telling people that really you have worked it out to the nearest tenth, since that's tenths, units, and hundred, and tens, units, tenths. So you've worked it out to the nearest tenth, and you know that there are no tenths. So that is why we put the 0.0 in this particular case. Part C of this activity gives us a formula for the volume of a cylinder as V equals pi r squared h. V is a volume, so it's a variable. Pi we know is a constant. R is the radius, so if you think of a diagram of the cylinder, it could look something like this, where the radius is this measurement and the height is that measurement. So the volume of a cylinder depends on the radius, how big the circle is of the cylinder, and how high it is. In this particular case, we are told, first of all, R is 1.5 and H is 8. R equals 1.5, H equals 8. So I can substitute these values for the variable R and H, and I get V equals pi times R squared, 1.5 squared, times H, which is 8 in this particular example. I now just take my calculator and do the actual calculation. I should have mentioned, when you're finding pi on the calculator, you don't put in 3.15. You don't type in the number, because your calculator will have somewhere, there's a button. It may not be there. It may be above a certain button. But either way, pi is built into your calculator. Your calculator knows the value of pi to about 10 significant figures, and that is much more accurate than anything that you could type in. So therefore, we use the built-in value of pi. So I'm going to say it's pi times 1.5 times 1.5 times 8, and I get 56.548 ... I want 3 significant figures, 1, 2, 3. I look at the fourth significant figure, which is 4. It's less than 5, therefore it does not change the third figure, which is 5. So I'm left with 56.5, correct to 3 significant figures. And part D, finally, we are given the formula C equals square root of a squared plus b squared. As it's a formula for working out the hypotenuse of a right-angled triangle. We are told in the first part that a is 1 and b is 2. So if a is 1 and b is 2, then c will equal the square root. We're just using the formula. A is 1, so a squared will be 1 squared plus b squared. B is 2, so it's 2 squared equals square root of 1 squared. 1 times 1 is 1, 2 times 2 is 4, 1 plus 4 is 5. Square root of 5, I don't know what it is, but my calculator does. So I press square root button of 5 equals 2.23, sorry, 2.23606, and so on. I look at 1, 2, 3 significant figures. I look at the fourth one is 6. 6 is over halfway, it's 5, it's more than 5, so it rounds up the 3 to become 4, so I get 2.24, correct to 3 significant figures. And the last part of part D, we are told A is 3 and B is 4. So in this particular case, C equals, I'm using the same formula, C equals square root of a squared plus b squared, but now A, instead of a squared, I write 3 squared, plus, instead of b squared, I write 4 squared. So it's the square root of 3 times 3 is 9, 4 times 4 is 16, 9 plus 16 is 25. And the square root of 25 is a very nice number, it's just exactly 5. We don't have to say 3 significant figures because it is exactly 5.